Hello, everyone, and a very good afternoon to all of you. I am Geeta, and it's my pleasure to welcome you all on behalf of Wind Insider and First View Group for an amazing webinar on developing wind turbine blades for the future. This virtual platform has brought all of us together to gain some great insights from some of the leading industry pioneers and sector technocrats on design and shape optimization for increased efficiency of wind turbine blades. Over the past decade, the wind energy industry has achieved significant improvements in energy production and cost efficiency, driven in part by evolving turbine, blade, and tower technology. Though it is in a nascent stage right now, but India still is one of the largest onshore wind markets in the world, and also a primary market for supply, trade, and investment opportunities in the wind energy segment. So, ladies and gentlemen, without any more delay, we would try to increase our understanding on this sector through this forum. However, at this moment, we would also like to thank our event partner, LAP Laser, which is one of the world's leading suppliers of systems that increase quality and efficiency through laser projection, laser measurement, and other processes, for extending their support in conducting today's webinar. And I would also like to invite Mr. TK Chau, Regional Sales Director, LAP Laser Applications Asia Pacific Private Limited, who will open today's webinar through this technical presentation on improved wind blade layout process using laser projection. So before I hand over the screen to Mr. Chau, I would like to make a small announcement. So dear audience members, don't forget to write in your questions for Mr. Chau in the Q&A segment, and it will be taken up after his presentation. Now I would like to welcome Mr. Chau. The screen is all yours. Mr. Chau, could we start with the presentation, please?
Thank you, Geeta. Thank you for the introduction. And good day, everyone. A warm welcome to the participants of this webinar. It's great to be here with the other speakers and panelists who are industry leaders and experts in their field to share, to talk, and discuss ideas about developing wind turbine blades for the future. Let me share my screen and presentation. As introduced by Geeta, my name is TK. I'm Regional Sales Director at LAP. And to be honest, I'm just going to put a disclaimer out there that I'm not an expert in wind blades. But at LAP, we provide laser measuring and guidance solutions that are used in the manufacturing of wind blades. So I'll be happy to start this webinar off with a short techno-commercial presentation of our lab laser projector system that can improve the wind blade layout process. Looking at wind trends, LAP understands how this has affected wind turbine blades, both in terms of production demand as well as design. According to the GWEC, global world power capacity is expected to reach 817 gigawatts in 2021. And also, India has set an ambitious 2022 renewable energy goal of 175 gigawatts, of which 60 gigawatts is supposed to come from wind energy. So with such ambitious goals and increased demand for blades, there's strong pressure to innovate and think of ways to reduce cycle time for blade production. There is also an increased trend for offshore wind power, which has become more and more economically viable, and wind blades are also getting larger as well. And with larger blades, they need to be more robust, stronger, and of a higher quality. So the question now is, how can wind blade manufacturers lower their cycle time, improve the production rate, and improve the quality of the blades to keep costs low, increase profit margins, and to keep up with these demand pressures? Now, there are many processes that blade manufacturers can look at improving. It could be in the materials they use, the design of the blade, inspection or curing processes, But today, I will be focusing on how LAP can help blade manufacturers in their layup process, because the layup process is very laborious, time-consuming, and susceptible to errors. With this, I'd like to invite everyone to dream a little with me. Imagine an entire blade layout process where there will be no need to make physical markings on the mold, no need to make manual or extrapolated measurements. Operators just need to follow laser lines on the mold to lay out various materials from the root end of the mold all the way to the tip. And operators can step through the layout process and show necessary lines at the click of a button. So, well, this dream can be a reality with the LAP CAD Pro laser projection system. And this is our value proposition.
Mr. Chau, I'll just sorry to interrupt you in between, but we are not able to see you. If you could just switch on your video.
Okay, there we go.
Thank you so much. Perfect.
All right, perfect. Let me show a short video clip of our value proposition. So on the mold, the laser lines will be able to show the location of the center line, glass fiber, balsa wood, other root area materials, show web, and locations of other things for infusion prep. All these locations will be shown to scale and to millimeter accuracy on the mold. This illustration next will take you through how our laser projection system works. Firstly, the laser projectors are mounted above each half mold at a height above the moving factory crane. This is a scalable solution. So that means if the blade mold is longer, then more projectors can be added to the solution to cover the length of the mold. The laser projectors are connected via cables to a control cabinet that has a PC with our software installed on it. CAD data showing the layout material locations on the blade mold is loaded onto this PC. And this CAD data is created by the blade manufacturers and are designed using software such as Siemens, FiberSim, and Cartier. Any of these CAD data file formats are compatible with our laser projector system. The CAD data is then projected accurately onto the mold as laser lines and templates. It's also possible to project text as well as the layer names. These laser lines will be drawn to scale and to millimeter accuracy. Operators will then move through the layout process from step 1 all the way to the last production step, and they can control this using a remote control, PC, or tablet. The next picture shows roughly how the system looks like from a factory plan view. The red rectangles you see on the screen, they represent our laser projectors, and they are located above each half mold. The projectors are usually mounted at a height above the moving crane, and that usually puts a distance of around, they're mounted at a height of about 10 to 15 meters above the ground. And we plan it such that each projector covers roughly about a 10-meter segment of each part of the blade. All the projectors will communicate and share information with each other so that they will project a complete picture across the whole length of the blade. Now let me illustrate to you how all this translates to value for the customer. Now that all the alignments and the lines can be seen instantly and accurately by just following the laser lines on the mold, operators do not need to make markings or manual measurements anymore. This means that your workforce can be more efficiently deployed to other tasks. And the entire blade layup time will be significantly reduced, improving your cycle time, leading to a higher production rate, as well as more blades being produced per week. Because of the high accuracy of the laser lines, there also will be less errors during the layup process. The blades will be produced of a higher quality, and also means less cost of material wastage, less chances of possible scrapping of a rejected blade, and less chance of any costly premature failure. Following the laser lines also makes training of new staff and onboarding of new staff faster, and this will be also important, especially if there's any if it is a high staff turnover environment. Then using the laser lines will help to get the staff and operators onboarded faster in the production process. So to summarize, the LAP laser projector system would be able to lead to a lower cycle time and a higher blade production rate. More blades can be produced per week, and more projects can be taken up by the plant, and also sooner as well. With the accuracy of the layup greatly improved, the quality of the blades will be improved. There'll be less errors, less discrepancies, less rejections, thus reducing the cost associated with such errors. And you also can see that the workforce will be more efficiently deployed now that they do not have to do the measurements. And training will be a lot faster for new staff and operators. And all these benefits equates to high profits for the company. Now, LAP has been very successful in the wind blade market, and this is because we have very strong references. The reason for this is because our laser projector system was initially developed for the aerospace composite layup industry, which requires a very high degree of accuracy. Our aerospace composite layup references include Airbus, Boeing, GKN Aero, Spirit Aerosystems, UTC Aerosystem. And in India, we provide our laser projectors to customers such as in the Tata Group, HAL, Hindustan Aeronautics Limited, as well as the National Aerospace Laboratories in India. So LAP has basically transferred this technology and experience from aerospace composites over to the wind blade layup process. For the wind blade market, LAP's success comes from extensive trials and evaluations carried out by customers comparing LAP with other brands. Many of our customers started first with trials on a small scale and over a period of time. And then after they had seen the benefits of the laser projector system in their layup process and evaluated the results, they went on to implement our technology throughout their plants. Some of the trials were done using actual side-by-side comparison with other brands and using actual production molds. I mean, for example, even now as we speak, we're also taking up trials with other blade manufacturers such as Envision in Denmark, and they're testing out our system before they plan further implementation in their plants. So at the end of these trials and evaluations, it's clear to customers that LAP is a trusted and superior brand. For the wind blade market, our customers include Elion in China, and globally we have customers in Siemens Wind Power, LM Wind Power, TPI, Composites, and Vestas. In India, our customers include Vestas India, TPI India, and recently LM Wind Power at their Dabastepet plant. Some of the Nordex blades are also being made in these plants using our laser projectors as well. To date, we have supplied our laser projector systems to more than 100 wind blade lines globally. And with such extensive experience and having been selected by customers themselves after trials, it's clear that LAP is a brand and company that you can trust. So who is LAP? Who are we? And what do we stand for? LAP is a short form for laser application. We are a German company that's the leading supplier of laser projection and laser measurement systems that helps to improve the quality and efficiency of processes. We design our devices to be easy to integrate and operate, hence our claim for being simply precise. We have more than 35 years experience in laser measurement. We ship out an average of 15,000 units of devices per year, and we employ about 300 employees globally in 8 locations worldwide, and we have an average annual turnover of about 63 million, and we are ISO certified. These are our locations globally. We have 4 locations in Europe. Our headquarters is located in Nuremberg, Germany, which is near Hamburg. We have 2 locations in the US at Florida and Texas. We have a location in Shanghai for the Chinese market. And in India, we have our partner in India, High Performance Composites and Coating. And they have offices in Mumbai, Bangalore, and Delhi. And lastly, I'm from the Singapore office, and I handle the entire APAC region, which also includes India. And with that, I end my presentation. I know it's a lot to take in, but I open the floor to questions if anyone is interested to find out more about the laser projection. Please do submit your submit your questions in the Q&A chat, and I'll be happy to answer them. My contact details are also listed in the slide.
Okay, so Mr. Chau, that was a great presentation. We do have a few questions in the box by Mr. Philip. He says that, Mr. Chau, do you think there can be an opportunity of using LAP service, for example, when repairing blades up tower at site in case of multi-layer repairs?
Thank you for the question, Philip. Maybe to answer your question, the laser projectors are mainly used in the in-factory manufacturing blade manufacturing process itself. Once for the various layups during, I guess, from the first step to the last step of the layup, once the blade leaves the factory, it will not be possible, I guess, for the laser projector to show to help in the repairing of the blades up tower and on site, because the laser projectors will need to be placed at a certain distance and calibrated to the blade mold. So it wouldn't be used in that way for service of repairing the blades up tower and on site. So it's really more for the start, the production process in the factory.
Okay. So we have the second question by Mr. Manoj. He says that, is it possible to address the fabric wrinkles during the layup process through this technology?
For the fabric wrinkles, it wouldn't be able to. I mean, what it will do, it will be showing the outlines of the fabric. Let's say the glass fiber on the outer perimeters of when it's being laid out. So it will show the outer perimeter and the footprint of the fabric, but it wouldn't address the wrinkles itself. I guess that still needs to be done manually in that way.
Thank you. I have Mr. Philip again, who now wants to understand, do you see any future development for customization in future? Now, that's very interesting way he has put that future there. So he's asking, do you see any future development for customization?
One thing that we are developing and still in the process of developing is a camera system that pairs with our laser projector, so that it helps to monitor the production process, as well as to help ensure there's a high quality in the manufacturing process. So the camera itself will help in the calibration of the projector to the mold. In case there are any movements, then the projection will be automatically updated and shifted if there's any shifting in the mold using our camera system. And the camera also can be used in a way to as a quality check, QC process in monitoring the layup during the blade production process. So that's what we are having being done in the development process. I hope that answers the question. I see more questions.
Yeah, I do have. There's another question from the audience. What is the estimated time savings from using the laser projector system?
Okay. I mean, the blade layout process, I think, varies from blade manufacturer to blade manufacturer. So it's a little bit hard to say, but on average, I think the amount of time saved expected can be about around a 30% improvement in the layout process time.
Okay. There's one more last question. It is, what is the maintenance cost like for laser projector, and what is the level of support in terms of service?
Our laser projector is mostly maintenance free. You can use it till the end of life of the product. But the good thing is that for our new model of laser projectors, it has a laser source that's rated 3 times longer than other brands. So maintenance costs are quite low. So it's really not much maintenance at all, because it just lasts so long, and it doesn't require any further maintenance. For the APAC region, the service support will come from Singapore and Germany, and in India, we have our local partners supporting Indian customers with engineers for installation support and spares.
Well, I do have one more question that just popped up. It says, what is the level of accuracy we can expect from the laser projection system?
The level of accuracy depends on a couple of factors, but more or less you can expect an accuracy of a couple of millimeters. So about between 1 to 3 millimeter of accuracy in the laser line being shown on the mold. I see some more questions that.
Yeah, there is right away. So they want to talk about what is the estimated time saving from using the laser projection system? Are there any arrangements that we can try out a system like in a trial?
Yes. So I think, as I mentioned before, the estimated time savings is maybe about 30% improvement in the blade layup time. And there is a possibility to arrange for trial. We've done it before for many customers, so we can arrange a trial on a small scale, and over a period of time for evaluation. And then after the evaluation process, customers can choose whether they like the system and are convinced by it, and then can take that further after that trial.
There's one more question, from the audience. They just wanted to understand the area of coverage, as you already mentioned, and how many laser projectors would it take to cover, for example, a 70 blade?
So as I shared earlier, each laser projector is mounted above the moving crane. So normally it's mounted at a height between 10 to 15 meters above ground. We try to make each projector and plan it such that each projector covers about a 10-meter segment of a blade. And we usually also plan for 2 projectors at the root area. So from there, I think you can roughly estimate how many projectors would be required to cover a 70-meter blade, just based on the rough plan of each projector covers 10 meters.
Right. Thank you. Thank you so much, Mr. Chau, for answering all those questions. And I'm sure the audience now have the answers to all the questions they wanted to ask. And thank you so much for the lovely presentation. And thank you so much for setting up the tone for today's event.
I take one more question. I believe there are quite a number of questions in the Q&A box. Yeah.
Sure.
Maybe I can.
Yeah, there's Mr. Devesh, he wants to know, can it detect wrong material layup?
Correct. Okay. At the moment, we don't have that technology to detect wrong material layup, but it's something that we can look into definitely for the future. So what we have in the works is a camera, and the camera will try to document each production step along the way. So that is definitely something for the future that we can develop. And thank you for this feedback, and we'll definitely bring it to our R&D department to take up.
Okay. This Mr. Sagar, who wants to understand how much gain we can expect from laser projection technique in terms of PLF.
I think this might be similar to the estimated time saving. So I would say about a 30% improvement in the layup time.
Mr. Anuj wants to know, can it quantify the error of fabric cutting process?
For the fabric cutting process? Yes, I mean, I would think if the glass fiber is being rolled out, then definitely you can have laser lines to show the end of where the fabric should be cut. So as long as that's in the data, it will be able to show that on a laser line to show where to cut it off. Separately, if there's another area in which there are kits or glass fiber kits that are being prepared beforehand, then we actually have our laser projectors in the kit preparation areas as well, so that the laser projectors can show the shape of each glass fiber kit, and they can use the laser to follow that to when they cut out the glass fiber kits.
Right, thank you. Thank you so much, Mr. Chau, for answering all these questions. And thank you once again for the wonderful presentation and being a part of our event. We'll see you in the panel discussion too in some time. Yeah.
Thank you, now, and thank you for participants.
So now we'll move forward to our panel discussion. In today's esteemed panel, we have Mr. TK Chau, again, Regional Sales Director, LAP Laser Applications, Asia Pacific Private Limited, Mr. Akhilesh Mishra, Senior Director, Technology Center India, LM Wind Power Blades Private Limited. He is also our session moderator. Mr. Arvind Udupi, Head of Engineering, Blades NETC, Nordex. Mr. Shripat Kulkarni, DGM Supply Chain, Senvian Wind Technology Private Limited. Mr. Satish Subbarao, Head Wind O&M, CLP India Private Limited. Mr. Pitha Solanki, WWO, Blade Production, Wind World India Limited. Now I will just hand over the session to Mr. Akhilesh Mishra. Over to you, Mr. Mishra.
Yeah. So I hope I'm audible to all.
Yes, you are.
Okay. Hey, thank you, Geeta, for giving me this opportunity, and I'm really pleased to bid you all, and look forward to next an hour or so engaging and learning along with the rest of the panelists here, and then be able to we'll keep aside around 15 minutes of the Q&A time so that we can answer some questions, as we have a lot of experts here. So just to start with this, this particular, you can say, forum which Wind Insider has established, it comes at the right time in the backdrop of the Earth Day, which we have celebrated yesterday. And every day is Earth Day. And this is something which I would say very timely, and we are talking about energy transition, and definitely the wind turbines and for wind blades, as we say, that rotor is the motor. The blades have you can say, a huge role to play in this energy transition, which we are getting into. So we would focus on you can say, the technology trends which are coming in from the design and manufacturing, and then as well as you can say, what are the new sort of service solutions which we are seeing in. So we will hear from the leaders, and as Mr. TK would not be there with us throughout, I will begin with a question to him first, and this is just from a curiosity standpoint, like LM, as we speak, we are installing a lap laser system in one of our plants in Bangalore, which Mr. TK talked about. So my question, Mr. TK, is that there are inherent process variations which come in, say from the mold definitions which we have, or even from the measurement systems which we have on the layer cutting process. So, and as we rely completely on a laser projection system, in the absence of any other validation mechanisms, what are the limitations do you see in the current laser projection systems which need to be addressed to where we can ensure that we are making a product which meets all the customer requirements in terms of the shape and size?
Thank you, Akhilesh, for that question. It's a very good question indeed. And as with all new technology, when it's embraced by a company, there'll always be the initial teething questions and issues that will come up from it. Importantly, for the laser projector system and the mold, the blade mold, there will always be a slight mismatch between the theoretical CAD data of the blade mold to the physical blade mold itself. So part of how the laser projector works is that it will need to calibrate to the blade mold first before the laser projection happens. So we have to ensure that there's a very accurate process of the calibration, as well as measuring certain reference points on the mold first before and that's all part of the commissioning process of the laser projector to the mold. So we do measure many reference points on the mold first before the installation is complete. We need to verify those coordinates of those reference points on the mold. And on top of that, the CAD data of the mold itself needs to be looked at as well, in order to make sure that the theoretical CAD data matches that of the physical mold. So there will be some adjustments that need to be made to the CAD data, and that's all part of the commissioning process when we commission the laser projector system to the mold. We've done it for many lines already, more than 100 lines globally already, and it has given good results as long as there's that work process of making sure that the data matches with the mold. I know it's something, it might sound a bit foreign sometimes, but it's an experience that we have, especially in the aerospace composite market, because also for aerospace composite parts, the level of accuracy is required is less than millimeter accuracy. So we have the experience from there. The parts that are made from the aerospace parts have to be extremely accurate. Operators don't get anything else other than the laser lines, and as I guess the risk of anything going wrong for an aerospace part is also very high because it's carrying civilian passengers as well. So definitely this transfer of technology from aerospace to the wind blade manufacturing, you can trust the laser lines that our laser projectors produce on the mold.
Yeah, no, thanks, TK. I think you answered in the first part, because it is the mold to mold variation and how the calibration takes place. I think that is the point which I was looking for. So thanks a lot for the clarification. So now,
Mr. Mishra, sorry to interrupt in between. I'll just request all the panelists to kindly switch on their videos so that we can have everybody together on the panel.
Okay.
Thank you.
Yeah. Hey, thanks, Geeta, for the pointer. So I think we'll go ahead and get started. And I think we will keep our discussion focused on the onshore and in our current context, as Geeta talked about, that India remains a big market, even though of the delayed auctions and our DISCOM's help, still it's a huge opportunity out there. And as I would say, on behalf of LM Wind Power, which is having around 40% of the total blades which are installed are coming in from the LM Wind Power, and I say it with a lot of pride. And we have been engaged with most of our customers, and there are a lot of things which I look forward to learn here from you all. So to start with, coming in from say specifically going into the design part of it, and there is a lot of effort now as the blades are getting longer, tip speeds are getting higher, and which causes, you can say, challenges on the erosion and challenges on the noise. And at the same time, the rotor diameters are getting bigger, logistical solutions are getting more challenging, and focus is more on segmentation. So we would like to hear from Mr. Arvind, who is part of one of our customers, Nordex. And we would like to hear from him on how, as an original equipment manufacturers for wind turbines systems, how do they take into account these factors, and how does it specifically translates to blade design requirements and shape optimization strategies? So, Mr. Arvind, if you can share your experiences.
Thank you, Akhilesh. I think very good afternoon to everybody. As part of today's panel discussion, I am representing this from the Blade Engineering from Nordex Engineering Technology Center based out of Chennai. So I believe in the scope of the limited time that we have, I would like to touch upon some of the technical literature pertaining to the blade aerofoil optimization and also the blade performance enhancement. I think it is also necessary for me to reflect to the past before talking about the present and the future. So now, if I look at the past, I think by and large we know that as the days have gone in the wind sector, the wind turbine sizes and the wind blade sizes have increased. And we also know as a thumb rule that as the diameter of the rotor increases, your energy output also increases squarely. It's a square. So we have also seen a paradigm shift in the size of the rotors from 17 meter to over 100 plus meters, and much bigger rotors still to come along. We have also witnessed a growth factor of 7 in terms of the diameter and a growth factor of 150 in terms of rated power in the past 25 years. We have also seen a lot of advances in the aerodynamics for the rotor design, alongside with the availability of the lighter and stronger materials and advanced manufacturing methods and control strategies, the turbine control strategies for reduction of mechanical loads. I would say a general approach to increase the rotor diameter while limiting the consumption of the material quantity is largely dependent on the blade loading, understanding the blade loading. For this purpose, to maximizing the energy capture, the load control is devised, which is achieved for most of the large wind turbines through variable speed and adjustable individual pitch mechanisms. Now talking about the impact on the blades, blade shapes, and the aero factor. So we understand that the blades are impacted due to a lot of loading, the transient loading, the aero loading, the mechanical loading. We understand that the blades experience load fluctuations due to local gusts, wind shears, blade tower interferences, the yawing, and also the tilt misalignment at times. The set controls could be achieved by active or passive flow control devices on the rotor. If I reflect on the past, we have come a long way, and in the aero history, where a typical aviation aerofoil was adopted in the very, very early days. With devoted focus in the wind sector has evolved a lot of optimized aero profiles. We know, unlike aviation aerofoil, wind turbine experiences two inflow velocities: the incoming wind and the velocity due to the blade rotation. Both the velocities add up to the apparent wind, which generate the lift and the drag. The inflow angle is the result of the two velocity components and is generally chosen in a way that the aerofoil operates at the best lift to drag ratio. Now the power is generally controlled through the blade's pitch. Hence, with relatively small changes to the pitch angle, we can have a big effect on the power output. This way, the blade can be adjusted depending on the current wind conditions. Now, talking about the aerofoil characteristics, we know that any aerofoil experiences, the inner side of the aerofoil experiences a much higher angle of attack than the outer part of the rotor. In reality, we understand and we believe, we are aware that the blade is pre-twisted by a certain angle, theta, to avoid the stall and to operate close to lift to drag ratio. So each blade therefore has a specifically designed aerofoil shape, a chord length, and a twist angle. Now talking about the twist angle is a property of a blade which can be controlled. Meanwhile, the pitch angle is part of a control system of the turbine. However, due to manufacturing reasons, it may not be cost effective for us to create highly twisted blades. We have a lot of constraints when we talk about the molds, which need to handle the much needed twist angles. So it is not so simple for us to always optimize the twist angles from a manufacturability standpoint, though solution may exist from a design standpoint. So it needs to be a win-win. So as I have come across most of the blades, they usually limit their maximum root twist to about 18 degrees. So the basic idea, what is the basic idea then? So the basic idea would then be to keep a target lift constant for a particular blade section. This can be achieved by varying angle of attack relative to the wind inflow. So therefore, most of the concepts are based on modification of the aerofoil's flow circulation and hence lift according to the inflow state. Industries have come a long way to have customized aerofoils, taking cues from the American S series, the Dutch DU series, the Swedish FFAW series aerofoil, and also the Danish Riso series aerofoils. Furthermore, we could evaluate and optimize the aerofoil concavity. So if I have to say how exactly we could contribute from a blade standpoint, the aerofoil concavity in relation to the slenderness ratio, which would allow us, yeah.
Sure, Arvind. I think the fundamentals part of it is very exciting, definitely for many of us. And I would like you to focus on that how these challenges, as we are going to this particular generation of, say, onshore wind blades, we are looking at 80 to 90 meters, and say in the next 3-4 years. And how are these challenges you are seeing, say, from a OEM standpoint, and what are the strategies which we are having in terms of, are we looking at segmenting the blades, towers, getting the hubs to locations? Because when we look at specifically in India, the sites which are there in Gujarat and Tamil Nadu, now we need to move on to the next level of, say, sites which may not have the same wind speeds. So would like to understand that how, as an OEM, these challenges are translating to the blades for you.
Yeah, like I said, of course, segmented blades is certainly an aspirational area. So I think we need to look into the practicalities and the feasibility with regards to having the segmented blades. So just before I was actually making a point with regards to the aerofoil concavity. Okay. Now if we need to optimize the aerofoil, so from the aerofoil concavity, there have been experiments which prove that the aerofoil concavity, optimization in the aerofoil concavity will help us optimize the flow characteristics, sometimes to a level of 3 to 15%. So there will be blade aerodynamic performance improvement. So this is one thing, and increasingly, in addition to exploring segmented blades, I understand flat back profiles are currently been in use. So flat back profiles are also adding value. So they are bringing in value, and not to forget the VGs. The VGs, they create the strong vertices, and they ensure that the separation process is delayed. So in summary, Akhilesh, I would say in addition to the aero profile design optimization, we also need to explore the manufacturing readiness. So if I need to have no stall or delay the stall, so then there should be an ability of the mold manufacturer to manufacture a mold with a greater angle of twist. So that is, I would say, that would also be something which we need to answer along with our mold manufacturers. So having said that, I would conclude. So having said that, I would conclude any particular blade rotor size is designed for a particular wind class and for a particular tip speed ratio. Now, if I am supposed to say that I need, for a particular wind class, when I take a blade of a particular tip speed ratio, if I say that I need to operate this in all the conditions, transient loading conditions, and also during the heavy rains, then I would only say that you are cannibalizing the product. So we should have a more balanced methodology. Along with some improvements in pitch control mechanisms, because pitch control mechanisms also add a lot of value in scaling the blade performance. So I think with that, I would give the lead to you, Akhilesh. So thank you.
Sure. Hey, thanks a lot, Arvind. I think that's very helpful. And Mr. TK, thanks a lot for being here. I saw your message. So thanks a lot for being with us and sharing your expertise. So
Thank you, everyone.
yeah, Arvind made a nice transition to when we talked about the manufacturing, and that's where I would like to go next. And when we talk about the longer blades, uh, like it's in no doubt that the blades are getting longer, and that poses its own challenges which come in. And I think as far as you can say that from a design shape optimization standpoint, we talk about the value which comes in from the add-ons and the value which comes in from the technologies like flat back, which in LMD are adopting to kind of keep the root diameters still compressed so that the hubs can be rightly sized. And that is, however, we also need to look at the newer materials. We cannot make a 90-meter blade the same way as we made a 60-meter blade. And that's where we need to look at the next, you can say, set of evolution when it comes to the materials and the supply chain of what is sustainable to kind of keep our production running in a sustained way where the costs can be predictive. And there are additional challenges which are coming in from at least last 1.5 years due to this ongoing pandemic, which is a reality now, and our country is going through I'll just take 30 seconds to acknowledge that, but we are going through one of the worst, you can say, phases since our independence when you look at the current situation. And that is, so having said that, there are a lot of supply chain uncertainties, and as well as the expectations from the materials to, you can say, have more strength. And so we have with us Mr. Shripad, and who has got a lot of experience in this particular area around the supply chain development. And I would like to hear from you, Mr. Shripad, that what are the material challenges you are seeing apart from, you can say, we can see definitely a shift to carbon. But apart from that, what are the other things which you see on the materials front, which the industry needs to respond to?
Yeah, thank you, Akhilesh. I'm Shripad Kulkarni. I'm heading blade supply chain vertical with Wind Technology, Mumbai. As far as this blade cost is concerned, you must be knowing that this wind industry is facing problem of the cost optimization as far as wind turbines are concerned and blades. If you see, during 2017, government has started reverse auction process, and that time the cost of tariff was around 3.5 to 3.6 rupees. Now it has come down to 2.47 to 2.46. So there is major challenge across all Indian industries, and blade is not exception for this. And nowadays industries are going for big turbines, maybe for 2 megawatts to 2.5 or 3 megawatts, like turbines we are going for installation. And length of the blade is ranging from 60 meters to 90 meters, as you said rightly. So major challenge is how to minimize the cost of the blades. And another challenge, I will also ask some designers, blade designers, what is the alternate arrangement, like how you optimize the blade design so that weight of the blade would be minimized. The minimum, if you see the minimum length of the blade, 60 meters to 65 meters, it is ranging between 13 metric ton to 14 metric ton. So how do we minimize the blade weight all put together? And if you see for one particular blade, the consumption of glass fabric, it is around 8 metric ton, and for a resin system, it is 5 metric ton. So I would say the 90% consumption is only with resin and glass fabric. If you see the cost of the resin and glass fabric, since 2011, the cost of resin and fabric is always increasing. And recently, there is an increase of prices between 40 to 50% for infusion resin. So this is a very, I am worried about this, how to maintain the cost of the blades. And what kind of alternate material we can use against such kind of material. Mainly, blade is made of composite like resin and fabric. But what kind of alternate solution for this? That we have to think, looking with the cost aspects. And second thing is what kind of alternate material for balsa wood and PET material. There are certain materials we can think for using this material like Sarfoam. Sartex is they're developing this Sarfoam and they're launching this product. And this is made of some glass fabric and certain carbon material. So very specialized material we can use. We can use in place of balsa wood. And second is we can also think for bamboo strips. Bamboo is very easily available in India and it is environment friendly as well. There are certain items like sisal, flax material, then hemp and jute. So this could be the alternate material in place of balsa sheets, and we can do some composite material with epoxy laminates and bamboo sheets. So that is the idea, and I know it will take some time to develop this material, but natural source I would say it will be always preferable due to recyclable of the blade, because this is another challenging task, how to dispose of the blade.
Yeah.
So looking into all the aspects, we should think all these alternate solution.
Yeah. So I think very valuable inputs, Mr. Sripad. I think, and this particular call out to kind of strike the right balance between the sustainability as well as, I would say, what I call is, as an engineer, we would always like to have a definitive material property, and that's why you would like to have and probably the nature given solutions like the balsa wood or the alternate woods we talk about, we won't be able to control it to the same extent, but definitely, and that is where we as engineers have this challenge to kind of address it. To the questions which you posed, I feel that I can add some value there. I think especially as we grow longer, and in order to keep our weight lighter and basically the total hub weight lighter with the blades and get less load on the pitch bearings, there is a definite shift that we need to move to carbon, but how much carbon you can take, because the carbon supply itself is stressed. And then I think balsa supply chain challenges are well known from last couple of years. There is a high density balsa challenge which came in, and that is something which actually caused the complete industry to kind of rush towards the PET and PET or PVC foam when it comes to the core materials. And that suddenly shot up the prices on the foam. And then foam went out of the market. And so I think it just went in that all the blade manufacturers went to foam. And now slowly, the foam supply chain is getting, you can say, stabilized. As far as LM is concerned, we are pretty much switching to foam at this point of time. And it helps us on the weight. As far as recyclability is concerned, like LM is the first company which achieved basically carbon neutrality since 2018. And we are currently developing the first 100% recyclable blade in our partnership with the European government. And so there is a lot of focus, but definitely as the challenges you talked about, Mr. Sripad, it's very important to strike that right balance. And I especially like the jute thing, because that's one of the things which, especially in our Western Bengal part as well as Bangladesh part, that's basically a major production area, and if we can sort of make that happen and come up with a stable material properties around it with the right solution, why not? This certainly can be a good solution. So let me quickly now switch over to going into the production phase, and we have with us Mr. Pita, who has spent close to 20 years around the molds making things. So I would like to understand that as we talk about sustaining because when it comes to different phases of say new technology launches, we first need to sustain and make money on existing blades, and then we will need to be able to use that money to kind of invest in new technologies and get to the longer blades, longer and lighter materials. But we need to first mature our processes. And what are the next gen, you can say, how are we making our processes lean? What are the changes which are being driven in the shop floor and in our production shops? And so Mr. Pita, if you can switch on your video,
Okay.
you can
Yes.
talk about
Okay.
that.
Oh, okay, sir. Sir, I will talk about related to how to reduce the material wastage, how to lean the manufacturing process, and how to improve the efficiency of blade. No.
Yeah, go ahead, please.
Sir, I will start from mold. Actually, mold is the initial stage. So we have to maintain the mold, y-axis, z-axis, and x-axis. Means after every 50 blade, we have to check the coordinate of mold, and we have to make the set as per mold for efficiency. Suppose every mold is a different profile, maybe 1 mm, 2 mm is different. So we have to final product, 3 set of blade, we have to make as per mold. Suppose I have 3 to 5 mold, A, B, C, D. Then I have to make the set A, 3 blades, 1 set. Then we can improve our efficiency. Second thing, how to increase the productivity. So we have to, before starting the layer process, we have to prepare the prefabricated part first, then kit form glass fabric, reduce the for wastage. We cut the fabric like a laser CNC machine, roll, make the kit, and lay on mold. And third thing is blade manufacturing is laborious process. So we have to fix the manpower as per his competency. And second thing is we have to reduce the manpower, fix the as per mode.
Okay.
And second stage is blade joining, male-female joining. Because blade joining also a manual process. Same thing we have to address the as per allotment of workman as per his competency.
Yeah. Sure. Hey, thanks, Mr. Pita, for sharing these highlights. And I think now I would like to move to, as we went from the design, materials and manufacturing, the next phase obviously is that how are we managing our assets in the field? And that's where we have with us Mr. Satish Subbarao, and like to bring him in. And so how are we getting better when it comes to understanding, predicting the failures? Are we getting into a phase where we can look at using some of the digital analytics and say digital twin strategies where we can predict the failures and and basically avoid the, you can say, stoppages even before that happens as part of the routine maintenance. So it's like a preventive maintenance, which is done based upon an analytical model running in a computer, and which predicts that this is when your bearing is going to seize, or this crack is particular going to develop. So would like to understand from Mr. Satish Subbarao on what are the issues we face, and as he has got that particular background. So, Mr. Satish. Do we have Mr. Satish with us?
Yeah, thank you, Akhilesh.
Yeah.
At the outset, good afternoon to all the participants and my co-panelists. Just a few words on CLP. CLP India, we have a fleet of 874 wind turbines with us. The total capacity is about 925 megawatts. We have wind farms across 6 states, 12 wind farms, and with machines supplied by 4 leading OEMs. So the average age of the wind farm that we have at CLP is about 10 years. So you could say we are in the midlife. And normally when I see reports such as NEU, where they say the blades are designed for, some blades are even designed for 50 years. And IEC itself says the design life of the machine is 20 years. But when I see the condition of some of the blades, I'm really worried, because at 10 years, they look so, worn out. And so as part of this, I would like to share, narrate some experiences, and hopefully the designers and manufacturers can reflect on it, because you design, you manufacture, and then you move on to the next bigger blade. So I'm not sure if you get all the feedback about how the existing blades are performing. So hopefully in this session, I'll just try to address it quickly, being conscious of the time. So we have, blades for one of our machines, which is meant to have stall strips. And that's an older generation design. So these stall strips are used in these wind turbines that have active stall control instead of the independent pitch control. And now, and I'm supposed to have five such strips at the tip of the blade. And then it's just year 10, and 3 of them have disappeared out of the 5, just eroded and gone. So what I'm told is now those stall strips are not being manufactured any longer. And then, so how do I control? Because that was one of the ways of a passive kind of control of the wind turbine. And now I'm told I have to retrofit some vibration sensors into the blades, and then I can do an active control of the. So that led me to, assess the condition monitoring retrofits that are possible on wind turbine blades. So obviously there's not much literature or much knowledge available in the industry for condition monitoring systems to be retrofitted on blades. There are any number of literatures and vendors who can offer that for the drivetrain, but not so for the blades. So as part of the thing at CLP, we are evaluating a few things. One is trying to have a kind of a ping monitor. Some of you might have heard it already. So this we found is easy because it is non-intrusive. We don't have to get into the blade and do anything. We just install this ping monitor above the turbine door, and then it works on the principle of acoustic emission. So if there is a damaged blade, then it's going to emit a different kind of sound, which this ping monitor picks up, and that can tell you very generally that something is wrong in one of your blade. It can't identify which blade, or in that blade where exactly is the defect. So at least it prevents a catastrophic failure, because Akhilesh, you might have known, see, even the current process, the blades are inspected only once a year, and that to visual inspection, somebody having a conus spot device or a binocular sitting from the ground. He's doing it. And if the blade is dirty, and blades are not cleaned that often. So the quality of the image is going to be, he's not going to be able to make out exactly where the defects are, how many defects. So it at best a very high level. And based on that, the O&M contractors say, it is normal, it is fine, just a tick box, and it is gone. But suddenly we find next day, a blade is dropping off from the. So luckily we have those rapid methods now, drones fitted with optical cameras or thermal cameras, which we have started to use. And we are able to get, again, most of this is limited to the surface. So we still won't know if there is a subsurface crack and if that is growing at what. So that's why we are going to try this acoustic emission device by installing a ping monitor. But we understand there are more advanced technologies. There's a guided wave technology. I'm not getting much literature, but again, this has to be installed inside the blade, and it works. It generates an acoustic wave that is picked up by another sensor somewhere near the tip, and the quality of the signal that's picked up by this sensor tells you if there are some cracks or defects on the way. And another interesting one, but I believe it's still in the early stages, this fiber optic sensors. Maybe LM is already embedding them in their new generation blades. And but the challenge for me is how to retrofit that in an old blade. So I will seek some help from the industry on that in the days to come, because the fiber, anything based on the fiber won't have these electrical interferences. So especially if the blade is struck by lightning, this is not going to get damaged. But if I have those conventional strain gauges, they could get burnt out. And so, but this has its own challenges and not so proven. So the so-called FBG sensors is what we are trying to evaluate and see if we can retrofit. So another thing, another very difficult experience I've had at CLP is where one of the blades just dropped from the machine, and this was I won't name the OEM and all that. So for now, I'll just tell what happened. So finally, the root cause analysis said that there was some hydraulic oil that leaked through the pores of the blade, and then went in between the metallic inserts and the protrusion, and that area between them is resin rich, and you can't have proper infusion there. And the best thing is the hydraulic vendor claims that whatever leakage is happening is perfectly normal. That much of leakage is acceptable. The blade manufacturer says that porosity is normal in the vacuum process. So apparently two things manufactured normally cleared the QA/QC, but they have this horrible outcome in the end, because the hydraulic oil managed to get through the pores, and then it went into this interface between the metallic insert and the protrusion, which was resin rich. And so soon it got sheared off in the load, and there was no instrumentation to detect that. And so one day just one blade dropped. And then now we are still having to deal with that issue 5 years since the first incident. And we are closely monitoring the root gap. And an interesting name was given to this by the OEM. He called it unfamiliar gap. And now it's not so unfamiliar. We are seeing it pretty often. And so on a year, we are having to change so many blades. Once the root gap exceeds 1.8 mm, then it's no longer fit. And another thing that as blade designers I'm requesting is that, you know, the manual says you can't change one blade, you have to change a set because they're moment balanced.
Yeah.
And so what is the amount of imbalance that is tolerated? It says 0.2%. And now, you know, as the blades become longer in future, you know, trying to change a set is not practical. The downtime is simply too much, and the cost is also too much. So most of us are trying to do single blade replacements. And if I have to do that, then this moment deviation, you know, should be limited by manufacturer. You know, it should be less than 0.2%. So I don't have to worry if I get a blade from some other place. No, first I have to check whether I can even put it here. So these are some of the issues I thought I'll briefly highlight. And lastly, I mean, you already touched upon it, recycling. So in my fleet, I have about 2,500 blades that will come out in the next 10 years. So I don't know what to do with them. So the literature says you can build playgrounds with that. So that's all I see in the literature. And even to cut them, you need diamond cutters, you need huge amount of cooling water, which on site, you know, in some of the sites in Rajasthan, imagine where you're going to get all this water from. So is there any other way? I think the newer ones you mentioned, I think they are thermoplastics, so they can be remolded. But what about the older ones, you know, the thermosets? So what's the industry thinking, you know, in terms of recycling? Because already in the world, I think there are over 300,000 machines operating. And, you know, even if a small fraction of those blades have to be recycled, it's an enormous quantity. So I think the problem is going to hit us on the face in the next few years in India itself, because we are in that, you know, we've been installing turbines since the late 90s. So that's possible.
Yeah.
So I just thought I'll dwell on this.
Yeah. No, I think very pertinent and I would say insightful comments, Mr. Satish. It is really pleasure to hear you on that. So I think if I can just recollect and try to play that again, and I think my first comment would be that from a new technology perspective, I think you are on pretty much on similar lines on the thermal imaging, trying to use specific challenges are with respect to the how do we implement the, you can say, the current condition-based monitoring systems onto the retrofit blades, and how do we kind of get a real-time data, and without like how do we kind of use the old control system softwares which have been there, the old FedEx system or different control systems which are there. How do we integrate these new requirements, which probably require a better processor speed, more data storage, and without really giving a very costly customer solution? So I think that is more from a wind turbine OEM standpoint on how do we do it. So I would leave it there. Specific to the blade, we have something called a platform, like which is called Re-Inspect platform, which we have come up with, and it is primarily based on the thermal imaging system, where we are developing a database of, you can say, so it's like a AI assisted database, where instead of as an engineer, me making a call on a photograph, I have done it 1,000 times, and that data is available with the computer. So AI assisted algorithm kind of bifurcates it and looks at the thermal imaging data. And as we add more and more data into it, it becomes smarter. So, and that is something which is available commercially. Right now, it doesn't require any, it is as applicable to a blade installed 20 years back, versus now it's irrespective of the resin systems used, whether it is an epoxy blade or whether it is a polyester blade. So I think that solution is something which is very much in the scope. I really like that acoustic signature thing which you talked about. I think that's a pretty simple one, and it is still kind of does the job. in terms of at least knowing that why the acoustic signature is changing. So we can do a deeper dive and understand a lot better. The particular issue on the hydraulic oil leakage, I think that is something which we as an industry have learned, that is something which has been a failure mode. We do have a fix, and but definitely we cannot take out the blades and do it. So it is certainly implemented in all the next gen blades which we are doing. And your requirement on this moment balancing, so there is something which we are doing there, that once, because manufacturing process variations are inherent, and as Pita talked about, we can do our bit on how can we ensure that our blade weights are within the control limit plus minus 3 sigma or whatever control we have put. We would still have that variation, and we will balance it as a set and then ship. However, if the data is available in terms of how we are going to the, say, 3D model category, and we have a better understanding of what is the density, what is the viscosity which this particular blade got into, then we can actually simulate the weight of that blade, and we have a very good data of the CG measurement. And so you don't need a physical blade to balance the system. You get the 3 virtual blades and you do a balancing, and then the blade which needs to be shipped, what is the balance weight which you need to add, and what is the balance box which you need to add. So this is something which I would say it is in shape, but it is not yet in practice, and it requires more and more effort on manufacturing side to understand what we are producing. And so I think very pertinent thoughts. I'm really excited with. I think we have 20 minutes more, and I would just like to circle back and just bring focus on to the India market and the specific needs which are evolving for us in this particular region. Because when it comes to offshore, there are different challenges, different technologies. I see a comment from one of our, you can say, participants here about there are logistical challenges we are talking about in India and the state of Kerala. And so are these logistical challenges specific for the blades? And are we also seeing it for the rest of the systems like towers, hubs, etc.? And are these anytime driving, you can say, our ability to install the particular solutions for our customers? So I would go back to Arvind, and I would like to understand that when we are quoting, say, or a particular, when we are submitting our bids for a particular customer as an OEM, like how does it play? Because ideally you should go for the longest blade, and like which can give you the more power. Like in terms of, with a small footprint, you can get more power. You can go for 3 megawatt machine. You can go for 4 megawatt machine.
Sure, Akhilesh. Thank you. Yeah. Thank you for the question. So I believe one of the basic requirement which we would certainly look in is the AAP part. The AAP and with which combination, which particular combination of the rotor and the hub, we would achieve good annual energy production. So this is one of the things. So and we also know that the wind, basically the winds in India, we know, we are aware of the winds in India. So basically for low wind sites, we need good blades at optimum hub height. So this is point number 2. Point number 3, certainly logistics is a challenge. And I understand that we are having solutions like segmented blades and also logistical solutions that we are currently working on to have the blades onto the site. And increasingly, I would say one pertinent problem or pain area is the leading edge erosion. Of course, we have solutions. We have the PU, the PU solution. We have the PPT tapes. We have certain coatings, but still we are not there. I think once the blades go through the first monsoon, they start speaking. So this is also one of the area I would say, to summarize a few.
Yeah. Okay. So I think, yeah, that was one point which erosion we have not touched upon, and I think as a you can say one of the largest blade manufacturers, what I can say is that leading edge protection is one of the highest priorities for us, because as you all know that I think until recently, till Siemens produced the 108 meter, we were the longest. That's 107 meter, and that's in the offshore. We are the only ones who have a prototype running, and that is something which we cannot go and put on these solutions, especially in the offshore areas, kind of every year. So that is why our leading edge protection solutions, which now we have available, are now applicable for 25 years, because we are signing long-term customer service agreements with our say customers, and through the larger G renewable energy, which LM is part of. So we do have the leading edge protection solutions with the newer material developments, which we have worked with our research and development team of the larger GE, leveraging the aviation and gas power technologies. So that is something which is very much available, and that is what we are deploying in offshore, and we have that solution available for our onshore blades as well. And as I talked about that, for logistics, I think LM is currently the only one who is offering a segmented blade, especially on the GE platforms, and that two-piece blade solution is something which is very unique, and that can allow the industry to kind of meet its demand, especially in a constrained logistics market like India. So now, one question which I did not address from Mr. Satish Subbarao, and that's very, very pertinent, is about the sustainability part. And I think he talked about a real problem which the industry faces, and that is something where, so we are certainly, for the newer blades, we are looking at the materials. LM, as I said earlier, is looking at 100% recyclable blade. That is, we are currently having that effort like already on, and we are right now at our factory in Davaspet. Like, we basically, whatever our production waste is there, that is used, and to kind of get the aggregates which can be mixed with the concrete and can be used in the road pavements. So this is something which we have done, and we have also presented to our district commissioner Tumpur, and we are partnering with the local government to make sure that how we can help the society around us, and while taking care of our recyclability needs. And we have also had, I would say, a significant impact, and I would like to call out Mr. Satish Subbarao, that when it comes to PET foam, which we are now recycled PET foam, which we are using in our webs of the blades, we were able to replace 40 million plastic bottles which would have gone into the sea. They are now in our blade webs as the recycled PET foam. And so now how it would get back once it say decommissioned, and how so I think as an industry, there are certain group of, I would say, epoxy resin systems has got a different ability of how much you can recycle it to. Glass and polyester combination has got a different one. And I would say we would be somewhere around 70% in terms of our ability to take out. And now this challenge of how do you do it on site without introducing any additional or incurring any additional cost for the say the OEMs or the utilities, because you cannot again have the cranes, again have the logistics to kind of put it back. And I think that is a solution which I would like to hear from, that how Shripad and Pita or Arvind, if you would like to pitch in on that important one.
Okay, Akhilesh, could you repeat that, please?
Yeah, so this is about what Mr. Satish Subbarao asked, and I would like to hear your ideas about this important sustainability question about, say, he talked about that he's going to have 2,800 or 2,500, not sure.
2,500 roughly.
500, yeah. So how are we looking at providing a solution on, say, recyclability of this installed base, and which may be from epoxy or a polyester mix, and without really getting into the logistics solution of shipping the blade to a place and then doing it. So is there anything which like we are looking at, Shripad, from supply chain perspective on recyclability, which you can throw some light on?
Yeah, right now, this could be the major challenge as far as the recycling of the blade is concerned, particularly for longer blades. Again, logistic cost is involved. Then again, transportation cost. So many other costs are involved while disposal of the blades. Right now, some of the companies, they are using incineration process, means to scrap the blade and melt the blade into the machine and then scrap it. And some companies, they are using some scrap yards for storage of the blades. And after that, they are using some material over the material over that blades, and putting some soil over the blades, like that. So that kind of activities are some people are doing.
Okay.
Is there some use in the cement industry that I keep hearing every once in a while?
Yeah, it's basically the co-incineration, what Shripad was talking about. So it's basically the co-incineration, where you would be using the crushed, the crushed FRP material as an input in the cement industries. But yeah, of course, I think when I'm reflecting upon what Akhilesh is currently telling, where we are looking at ways and means of recycling PET and getting it back into the blade as point number one. And point number two, as also looking at possibilities of some kind of aggregates which is bringing into the construction of roads and such kind of initiatives. So I believe we need to our industries focus should be more in such direction. Co-incineration is certainly an existing process by the moment. However, I think the earlier one which was discussed, we need to look into such kind of recycling.
So a question to you, Mr. Satish Subbarao, and this is, I'm just taking a cue from what our event partners have told us. So, like, how are you basically looking at this next gen maintenance and operation technologies to kind of get more output from your plants and blades? Like, Are there digital twin strategies which you are specifically looking at adopting in your plants to increase the AEP? You're on mute, sir.
Yeah, we are looking at several options actually to increase the AEP with our existing blades. So we have tried to retrofit VG strips on the blades where either it was already not there or when it is found feasible, and that is giving us 1 to 2% AEP gain. We've just installed it and we are in the process of validating. So that is one thing we will do wherever possible. And then extensive use of drones for carrying out the visual inspection. Another thing that we would like to try is the use of robos for the ones that will climb the on the blade. It will do an inspection. Another set of robo can do the cleaning, and I believe we have robots that can do repair also in situ. So I'm not sure if the designers of the blade can also plan to design the robos. So it comes as a package to us. Otherwise, we'll be scouting the world over, to look for robos that can. So if that can be customized for a particular blade design, that would be much useful to us. Currently, we are doing it, through the rope access method, and that's involves a lot of downtime. Actually, just cleaning the blade cost us a downtime of 24 hours, and then the repairs that we did took another 40 hours. So that almost the good part of our low wind season went in doing this and left very little time for doing other regular PM activities. So if we can have a robo, and some overseas customers have offered us robos, but then the economics isn't working out currently. It's cheaper to use manpower and do the cleaning rather than employ robos. So that is something we are looking at. And with regard to the digital twin, I believe that is mainly for the SCADA data. And one of the vendors have offered us, and we are going to try it out soon. So that will, the digital twin will tell us, how much we should be getting and what we are actually getting, and then suggest some, I think there's a AI in the background, which will try to tell us where to look for improvements. So, but at this stage, we don't have much, hands-on experience with the digital. Maybe in a next 1 year or so, we will have.
Thank you. And if I can go back to Mr. Sripad, I think we talked a lot about the core materials, Sripad, and if I go to reinforcement, because it's a natural shift that we go for the higher length, we are going in for the, say, the carbon fabric instead of a glass fabric. But the carbon is more susceptible to wrinkles, so we go for a protrusion. And how does it, say, balance out?
Akhilesh, sorry, your voice is not audible.
Can you hear me now? Can you hear me?
Better.
Yeah. So, in summary, my question, Sripad, was around, as we switch from, say, strike a better balance on glass fabric to carbon fabric, do we see that we have the carbon supply chain in India, which can be scaled for the demand, like we are talking about? Say, our Prime Minister keeps saying about a huge target, and whether we have supply chain to kind of sufficiently provide the carbons which would be needed for that longer length?
Yeah, unfortunately, I would say it is not that much, because in India, there are no carbon manufacturers. Reliance is going to have their plant, but they have not started due to complexity of this manufacturing process. All the carbons we are getting from foreign countries like China, USA, and Germany. So in India, there is constraint of this manufacturing of the carbon. That's why it is too much costly.
Okay.
And we can't use carbon material for enter blade. We can use only for this structures only, not for that is one of the constraint. And again, cost will increase due to carbon.
Yes, absolutely.
And I would like to add one more thing about this blade scrapping process. Yesterday, I saw one photograph in which one school in the playground, they demonstrated some cut pieces of the blades, and it is very nicely demonstrated.
Okay.
And in some places, we can install these blade cut pieces as a, I would say, for some kind of innovative ideas we can have by using these cut pieces of the blades.
Yeah, no, I'm sure. I think that's what Mr. Satish was talking about, that he can make a playground. That's what he was about. And there are many of these, you can say, at the bus stop shelters. And I think we all have seen those pictures in different places on how the scrap wind blades can be used. But I think there should be a more productive way of, and that's something as an industry we need to respond, especially as in India, when we started from the 90s, and this is the time where one generation of the blades already are coming to an end. And as we transition to the next generation of the blades, we certainly will be faced with that challenge. So I think this is the time where I would like to now stop and take some questions specifically from the audience. So I will hand it over to back to Geeta now, and so that she can direct the questions to us. And so Geeta, are you there?
Yes, Mr. Mishra, I'm definitely there. I'll just point out a few questions for you. So Mr. Mazhar, he wants to know, he's addressing it to Mr. Satish. If I listen correctly, you referred to ROBOS, that does cleaning of the blades. Would appreciate if you could elaborate a little, how does it work and by which source?
Yeah, so at CLP, we don't have any, first-hand experience of robots being used for blade cleaning or repair. Though at our solar PV farms, we use robo extensively. So this is something I was actually wanting to understand more from my co-panelists, because these robots have to be developed, after knowing the profile of the blade and things like that. So presently, what I understand is there are these robots that can climb the wind turbine blade, but how do you get it up there? That's still not sure, because the wind turbine blade, to get to the wind turbine blade, you have to go 15-20 meters. So there's a lot of complexity involved. It's still early days, so I'm still scouting, for literature, and our holding company at Hong Kong is also working on it, and hopefully I'll have some pilot project going in the next few weeks. So then I'll have more information.
Yeah. So Geeta, I see a couple of specific questions related to what I can add value on. Can I take those?
Sure. I'll just request you to take on the relevant questions by yourself here and request it to the panel.
Okay.
Thank
you.
I
see one question on this, on the segmented blades, and are we still pursuing it as a solution for easier transportation? So this is something I say again with a lot of pride, that GE has this unique solution, which is, I would say, is completely tested, and we have it already available in production, in operation, and in testing. So this is something which is already proven solution, and this is, if I can I claim that this is the only proven solution on the segmented blade which has been in operation, and we are continuing to produce. It is not that this is something we will do it by default, because it comes with its own cost, and there are right markets where the jointed blade solution makes sense. There are markets where the jointed blade solution does not make sense. So especially for when we talk about our Prime Minister sharing a vision for Ladakh, where we have to take the blades to the Atal tunnel which has come up with, and if we have to get a longer blade in, then we need to go for segmented. So, and that is one of the solution which is available, proven. Coming to the RPET materials, so right now we use it only on the webs, because there are certain strength considerations which Mazhar we are working on, and I would say that we are still not approved to kind of use them in the shell core, and that is something which I would say, but we make so many webs, so it's just that we are not short of it. So we are recycling all of it what is available already for production in our webs, which we use. So now if I direct a question, and this probably goes to Mr. Satish Subbarao, that how often do you conduct maintenance and repair of existing blade turbines? And another one is, somebody is asking your email ID, and yeah, often, and what are the challenges to improve lifetime of this, like maintenance cycle interval, which you have, Mr. Satish?
Yeah, see, the more often you clean the blade, it's better. So it's a trade-off, basically. But at least after 10 years, you should mandatorily clean the blades, do a closer inspection, because our performance team estimates that you would have lost 1%, 1 to 2% AEP, simply because of the aging of the blades. And most of the O&M contracts don't cover the cost of this cleaning and repairs, because they will attribute this to normal wear and tear. And so that's a cost you must have planned for, because suddenly at year 10 it's going to hit you with a big cost. So this cost should have been factored in, and one low wind season you can put multiple teams. Like I already told you, the extent of downtime that will be required, but that was for a not a very long blade, that was more for a 40-meter kind of blade. So accordingly, the time will be, and you'll have to put up with this downtime as well. So it's better to plan it all nicely, have multiple teams if possible, and once in 10 years mandatory. And just the annual inspections, try to do it more often. If you leave it to the O&M contractor, he's just going to do it once. I think after the high wind season, you should immediately do it, because there's a lot of lightning damage that just goes undetected. And unless one day somebody tells you there's a black scorching mark on your blade, and then it's pretty, lightning, is not much understood actually, unfortunately. And we always tend to think the lightning will strike at the tip of the blade, where we have all those nice devices, which can take all the charge to the earth. But lightning has a bad habit of striking wherever it likes. So we've seen lightning strike near the root of the blade. So how do you, and there is no sensor, unfortunately, again, which can tell you a lightning struck your blade yesterday. So this has to be, somebody with the Konuspot device has to be looking at these blades often. In my team, I have one guy exclusively doing only this, because at one of our wind farm sites, every year we used to have 4 or 5 blades, lightning strike, and nobody knows when it happened. So when we go to the insurance, the first question they ask is, when did it happen? So we say we don't know when it happened, but we detected it yesterday. So they have been kind enough to compensate, treat it as an FM, but we don't know how things will change. So at least for lightning, please check if your site is prone to lightning. You should do it just after the start of the high wind season, before the monsoon. No, that's when the lightning strikes are more. Otherwise, twice a year, do a general monitoring. Cone spot devices are not expensive, but they're pretty accurate. You can even attach a camera onto it and take the photograph and show it to the manager. And after 10 years, you must do this. You believe me, you'll find a lot of damages after 10 years. Even a good site, you might not know a lot of leading edge wear and tear, and so you'll be surprised. So better is to budget some amount, do it after 10 years.
Got it.
I hope that answers the question.
No,
Thanks.
certainly it does, and it does it very well. There is one question which I will take, and this is specifically addressed to myself, that what is the different glass and carbon protrusion technologies that we are using in India for longer blades or segmented blades? So Manoj Mistry, so India primarily for us, like we have almost 1/3 of LM's production capacity stationed in India. And it is not that all those blades go into the India market, because we are exporting. And so we provide blades for Americas, we provide blades for Europe, Australia, Vietnam, and many other markets. And we are already using the carbon protrusion technologies for many of our blades, which we are producing in India. There is this expertise available within the India team, which we have developed, where there are engineers. Our engineers are designing the carbon protrusion blades. Our engineers are making those carbon protrusion blades. Our operators are well trained, and we are among one of the best when it comes to getting these blades done in India. And we are actually setting the standard when we look at either within the say 15 plants which we have in LM, or even in the larger, you can say, perspective of the other blade manufacturers which we see. So I'm really proud of the team in India on how we have been able to kind of get into. Till now, we are not into the glass protrusions, but we are looking at the different, you can say, especially in the cost-sensitive markets like China, where we cannot switch to carbon immediately, and China has withdrawn its own equivalent of PTC. The cost numbers have come down drastically there. So, and there are a lot of challenges in China. So we are looking at how can we go for the high modulus glass and the glass-based protrusions, but that's just, I would say. So there is another one which I think Arvind or Mr. Satish or Shripad or Pita can take. Is there any technique to increase PLF through some modification in existing blade? So
Like I mentioned one already, and that was talk to the OEM and see if you can retrofit VG strips. I think Arvind spoke about VG strips. And then, yeah, so there some people claim there's a special kind of coating which will delay the onset of the leading edge erosion. And you could try things like that. But besides that, what other modifications on the blade is possible, I'm not very sure at this stage, because blade comes as a customized thing. There's very little you can do to it besides adding VG strips. And the only thing is try and delay the onset of the failure, or if there's a failure that happens, try to know it as soon as it has happened. So
we call them add-ons, like any add-on which we apply, and those add-ons include the, say, VGs, sedations, or the noise control features, or the leading edge protection systems. And so we used to have this Pro Blade solution, which was applicable for a certain time frame. But now we do have a more robust solution, as I talked about earlier, which goes for longer, say, durability and reliability. Because we are developing solutions which we now have to sign a contractual agreement for, say, 20, 25 years. And that requires us to guarantee the performance of the, say, blade availability over the number of years. So hope that answers the question.
I have one. I see my name there. There's a question related to acoustic thing monitor. The answer to that question is no, we have not validated it. In fact, the manufacturer also says he will do a research once a certain amount of data is gathered, because it's very difficult to correlate the kind of acoustic signal with a particular failure. So I think that's also in a R&D mode, and we want to be part of that effort. So that's why we are going into it. We've not done the validation. In fact, we are going to start work on that after this high wind season is complete. But you can contact me if you want to know who's the supplier of that. I can share some details.
So there is a very, I would say, elaborated question by Mr. Jairaman Punithan, and he's from NHPC. So my answer to you, Mr. Jairaman, for this question is that as an industry, it's not about, we are not trying to win a race on who makes the longest blade or who makes the, you can say, the biggest blade. And it's always about how do we add value to the customer. And there are solutions which are available in LM, which are from, say, 13 meters to now 107 meters. And it is always about finding out what is the customer requirement. So a customer approaches us with their wind profile and the loads which are expected at their site. And then we provide them the right blade solution. And I would say how it happens is that customer goes to the wind turbine OEM, and then wind turbine OEM, whatever their turbine can take in terms of the blade weight and the loads relatively. However, when it comes to LM, what we can provide uniquely is, even if turbine is limited, and because turbine is limited because of the hub size, or because they know that they cannot take this much bigger blade there, there is a specifically in India on this unique two-piece blade solution which we have, we can pretty much get a 40-meter blade to Ladakh, and which I don't think there is any other, you can say, blade manufacturer who can claim that. So, and I just take the name of Ladakh because from a logistics standpoint, it can be one of the most challenging places. So I would say welcome to hear more, but we are just about time, and I have really enjoyed being part of this panel and learning from you all and sharing my view with you all. And I quickly hand it over back to Geeta, and once again, thank
Akhilesh, there is one last question for you, I think, here. Somebody has said 0.2% balancing tolerance is for manufacturing. I guess considering safety margin tolerances are a bit higher, 0.4 to 0.5%. Any thought on that? That's the question.
Yeah.
For the moment deviation. You know?
Yeah. No, certainly when it comes to okay, in the chat window, I didn't see in the chat window. I thought it was. Yeah. So I think this is something which is certainly we need to look at the records which we submit to our certification authorities. So we have the records and documentations, and if this is something which comes to, then there is a documentation for each blade set which is available, and which, as I talked about, Mr. Satish earlier, that as we are moving to more and more of the digital form of understanding that what is the each blade CZ, what is the each blade profile. So we have the virtual blade available in our database. So, and then we can create a new balancing set and the new requirement of that, whatever that new additional blade which you need to provide with the right balance chamber which you need to put in the third blade which you need to replace. So we certainly will have margins, but it has to be evaluated on case by case basis on which margin will get, you can say, compromised and how much margin we had specific to that. So that will be my answer to Gaurav for that. But I think with that, I would like to stop here and hand it over back to Geeta. And thanks a lot once again to all the panelists and all the participants.
Thank you. Thank you so very much, Mr. Mishra, for an amazing moderation. Thanks a lot to all of our panelists for a wonderful and insightful session, for sparing their precious time and also extending their support for the event. I would also like to thank each and every audience member who has joined us today. With this positive note, we come to an end for today's event and promise to come back with more knowledgeable driven webinars. So till then, stay safe and stay happy. Thank you all.
Thank you.
Thank you.
Bye, thank you.